All right, so we've talked about how sine and cosine are functions of an angle, meaning you put in an angle, it gives you a number. So it makes sense that we would want to graph them. So we're going to use the unit circle and the special angles that we've learned about to make graphs of sine and cosine. So on the x-axis here, on the horizontal axis, I'm actually going to label this axis theta to emphasize that it's an angle. And this is telling us what's happening as we move around the circle. You might remember that the sine of an angle is the y-coordinate as we move around the circle, and the cosine is the x-coordinate. So here at an angle of 0 degrees or 0 radians from the positive x-axis, the coordinates of this point are 1, 0, meaning that the cosine for an angle of 0 has a value of 1, and the sine for an angle of 0 has a value of 0. So I'm just going to label this point cosine of 0 equals 1 to help you understand a little bit what these graphs mean as we build them out. Okay, we will get to these in-between points to sort of flesh out our graph, but as we sometimes do when we're graphing something using the graphing calculator to make a table, it's often easier to look for the whole numbers and graph those first. So the next point that I'm going to graph for these two functions is going to be this point, which is the point 0, 1. This angle is 90 degrees from the positive x-axis. So what is that in radians? A half circle is pi radians. This is half of that half circle. This is pi over 2 radians. So what this means, this angle is pi over 2. The cosine of pi over 2 is 0. And the sine of pi over 2 is 1. So our graph is somehow going to connect these 2 points on this graph for the sine. And it's going to connect these 2 points on this graph for the cosine. But we don't know what that shape really looks like yet in between, so we'll come back to that. Let's do this next easy point. The angle here is pi. The coordinates of this point are -1, 0. That means I put a -1 for the cosine because that's the x-coordinate, and a 0 for sine. The coordinates of this point are 0, -1. And this angle is 3 pi over 2. It's 270 degrees starting from the positive x-axis, or it's 3 pi over 2. Pi gets you halfway around the circle, and then it's another half a pi to here. Oops. So I could interpret this 0 as meaning the cosine of 3 pi over 2 equals 0. This -1 means the sine of 3 pi over 2 equals -1. So the cosine is 0, the sine is -1. I'm going to add these points to my graph. This is a good example of how the unit circle can give us a value for a sine or cosine that you couldn't get in a triangle. If we were only defining our trig functions using SOHCAHTOA, you wouldn't ever get an answer like -1 because you wouldn't get a negative ratio between sides. And even 0 wouldn't really make sense for a triangle. That would mean that one side basically doesn't exist at all. Okay. But with the unit circle, we can answer the question. If we start at the positive x-axis and we go 3/4 of the way around the circle, that's what that 3 pi over 2 means. What are the coordinates of this point? And those coordinates are 0, -1. We call the x coordinate the cosine and the y coordinate the sine. Okay. The last thing on here is 2 pi. You might notice that this is the same point as an angle of 0. As we talked about, you can have multiple different numbers for the angles referring to the same point on the unit circle. And because the sine and cosine describe the coordinates of that point, what that means is that whether we have 0 or 2 pi, we're going to get the same answer for the sine and cosine. The sine of 2 pi is the same as the sine of 0. It's 0 because the x coordinate, or the y coordinate of that point is 0. And the cosine is 1 again. And then, if we were to continue going around the circle, we would get the same repeating pattern as we pass through these 4 points. Sine would go from 0 to 1 to 0 to -1. And then repeating that pattern, 0 to 1 to 0 to -1. Based on the y coordinates as we move around the circle. And the cosine would go from 1 to 0 to -1 to 0. 1, 0, -1, 0. It would keep changing between those values as you kept going around the circle. Okay. I haven't connected these points yet. You can see they kind of make a zigzag shape. But let's try to make the shape a little bit more specific. So to do that, we're going to use the special angles to fill in more values in between these points. Okay. So, for example, this angle is 30 degrees, or pi over 6. And it's 1/3 of the way between 0 and pi over 2. I've got 6 boxes here, so 1/3 of the way means it's 2 boxes in is pi over 6. And the value here of the y coordinate is positive 1/2, which is halfway to 1. There we go. A couple ways to remember this. We could draw in a little reference triangle here, and that lets me see that I've got the long side along the x-axis, that's square root of 3 over 2, and the short side is in the direction of the y-axis, so that's a y-coordinate of positive 1/2. So the sine of pi over 6 equals 1/2. That's what this point on the graph represents. The cosine of pi over 6 is the square root of 3 over 2, which comes out to be about 0.87. So again, 2 boxes in along this scale is pi over 6. And my cosine is 0.87, which is about halfway down this first box here, right there. Okay. Now let's think about this point. think about what the angle of this point is in radians. This angle is pi over 4. It's halfway between 0 and pi over 2. So that's going to be 3 boxes in. Pi over 4. And if I were to draw in this reference triangle, these two sides should be the same length. They're both square root of 2 over 2. What that means is that based on this number, the sine of pi over 4 equals the square root of 2 over 2, which is about 0.71. So right about here. And the cosine of pi over 4 is also about 0.71, which is right about here. Okay, now let's do this angle. This angle is pi over 3. You might remember 60 degrees is pi over 3. I have 3 of these 60-degree chunks to get to pi. So the angle that goes with this point is 60 degrees or pi over 3, and it's 2/3 of the way to this first quadrant transition. So it's right here on the graph, pi over 3. The coordinates of this point are the same as this one, just flipped around. Oops. 1/2 square root 3 over 2. Because I'm halfway in this direction, and I'm most of the way up in this direction. This is the longer side of that 30, 60, 90 triangle. That y coordinate is square root 3 over 2. Along the x-axis, we have the shorter side of that triangle, which is 1/2. So this 1/2 corresponds to the cosine, because it's the x-coordinate, of this angle, which is pi over 3. The cosine of pi over 3 is 1/2. And the sine of pi over 3 is 0.87. There we go. So now that I have some points in here, I'm going to connect these points together and I get this sort of curve. And something you might notice is that these are they are the same exact shape, just flipped around. And as we continue the graph, we're going to get more of this same shape again. Okay. So I'm going to try to go through the rest pretty quickly, because from here it's all going to be the same numbers and the same concepts, just some of those numbers will be negative. So I'll focus on the sine graph first. As I go to this next point, the y coordinate is this 0.87 again. That's right here. Then it's down back to 0.71. Right here it goes with 1/2. And then we're over here. If I wanted to, I could label these angles with their radian amounts, but you could figure it out from sort of the fractions that we talked about before. I'm just gonna move along and fill in the rest. But on each sort of section here, we'll have these 3 points representing the special angles that fall into that quadrant. And we're gonna get the same curvy shape every time. So I can connect these now. Now, after I get to pi, my next angle is this one. The sine, the y-coordinate, is -1/2, which is right here. Next one is 0.71. And then the next one is 0.87 again. Here we go. And then this last one, quadrant 4. This angle is, the sine, the y-coordinate is -0.87. The y-coordinate of this one is around -0.71. And the y-coordinate of this one is -1/2. And then we can connect this back up. Okay. So, you might have heard the term sine wave before. That is describing this shape. And this plot is telling you what is the y-coordinate as I move around the circle. If I start here, the y-coordinate starts at 0. It increases until it gets to 1. Then it starts decreasing again. It hits 0. It keeps decreasing and becomes negative until it gets to -1. And then it increases again to get back to 0. Now let's make the same graph for the cosine. So we left off at the end of quadrant 1. And now we're going to think about the x-coordinates of each of these points as we go around. Oops, I put this point in the wrong spot. I didn't line it up correctly. There we go. Okay, so after pi over 2, which is right here, our next angle is this one. And the x-coordinate of this point is -1/2. The x-coordinate of this point is -√2/2, or around -0.71. The x-coordinate of this point is around -0.87. Oops, that's in the wrong spot. Oh my goodness. Here we go. This point shouldn't be here. Sorry about that. We can continue going around. The x-coordinate of this point is again -0.87. The x-coordinate of this point is -0.71. And the x-coordinate of this point is -1/2. Here's the next shape. So in each section, we basically see this same little curve repeated upside down or backwards, but it's always the same shape. In our last quadrant, we have an x-coordinate of +1/2, an x-coordinate of about +0.71, and an x-coordinate of about +0.87. And I will connect these up. There we go. So this shape is describing what happens to the x-coordinate as we move around the unit circle. The x-coordinate starts at +1, then it decreases to equal 0, then it keeps decreasing and becomes negative until it gets to -1, then it starts to increase until it gets back to 0, and then it increases again until the x-coordinate again becomes 1. Great. So we now see a graph of the function sine of theta and the function cosine of theta. We'll talk pretty soon about function transformations on these, which have special names, but they're the same ones that we've been talking about: vertical and horizontal stretches and vertical and horizontal shifts. And we'll talk about things like the domain and range of these functions, where they're increasing and decreasing, all of that good stuff. I want to add one more thing to this graph, which are arrows. Because even though we went around the whole circle and we saw all the places on the circle that it was possible to be, we didn't technically explore all the angles that we could have, because it's not like we can only walk around a circle once. You could keep going. That would represent going further to the right, or you could walk around the circle in the negative direction. That would represent going to the left. And in either case, you could continue the graphs along either direction. And they actually would just keep going up and down as you go along the circle. The x-coordinate goes between 1 and -1, and the y-coordinate goes between 1 and -1 as well. All right, thanks for tuning in. Hope this made sense. We'll get more used to these as we go on.